It says we're live, but it could be lies.
Lies of live. Says we're live. Welcome everybody. Hi Wendell.
There, now we can see you. Oh, nope, Discord is like, what's going on? Discord, you're frozen in Discord. No.
I think you're fine over here.
There we go. Woo!
Woohoo.
So we're simul streaming. We're streaming on both things. But this is the first time that we've streamed since you're not with Anantech anymore. You're doing your own thing.
Oh yeah.
I am very vicariously excited for you. There's something that's liberating about that. I don't know why. It's like, oh, I'm changing everything in my life. It's like, I'm very envious of people that can do that.
It's something I'd been thinking about for a while, and just, combination of everything comes together and you think, let's make the jump. It's the right time. Demand for semis is high. There seems to be a lot of need of good
Everything.
marketing. I don't know. I don't know. I have this thing on Twitter where I call out where somebody uses a Socket 775 processor to talk about modern chips.
Yeah, I think you could
I
probably make a lot of money doing stock photography just on that, and be like, "Here's my stock photography thing."
it's I actually found that the Intel Capital investment arm, their Twitter handle uses a picture of a Socket 775.
Yeah.
So, but we're here today to talk about one of these. Except no, this is second gen, but third gen
They
Milan.
didn't change the box.
Did they not? Did you actually get a proper retail box with your sample?
No, no. I bought an ungodly number of epics on top of the. Most of the time they don't even come in a box. But if you do get like one from Newegg or something like that, they come in a box. And as far as I can tell, they didn't really change
Yeah.
the box much.
But it's still got the, so Milan had the grey packaging handle, didn't it?
Yep, yep.
What do you call those? The holders. So, and Milan-X still has, it's still grey, so they haven't changed that.
No, and I was noticing the other day that there are at least a few OEM systems out there in the wild that don't even have the little plastic thing. So I was looking at some pictures. There was some people doing maintenance in the data center for me, and I was like, "Just do this. It couldn't be easier." And they're like, "What are you talking about? It's not like that." I was like, "Bro, I've taken apart a couple of these servers. I think I know." And no, sure enough, there was no little plastic thing in the CPUs in that. I don't know why. So it turns out that on
It,
Thingiverse and a couple other places, there's 3D printable versions of that, and now I know why.
it saves that tenth of a cent that you need so much. I have seen people spray paint them pink. So, if you want to customize your Epic server further, a system that nobody will ever see. That
Well,
being said, you've put a few Epics in workstation chassis before, haven't you?
yes. Not only that, I've gone so far as to almost sort of kind of prototype a PCIe card that combines a sound card, a NIC, and a USB controller, so that you can have one device that's not even necessarily a PCIe card. I've sort of had in mind to build it so that you could plug it into one of those 8-lane headers, and from the 8-lane header, just put it somewhere in your case, and then it's like, ta-da! It's a chipset on a card. Woo!
Yeah. Yeah. So sometimes you do need that sort of breakout, don't you?
Yeah, but I've had pretty good luck. Usually, especially with server boards, they expect a lot of airflow over the VRM, and we've had people on the forum do the same thing, and they're like, "Oh no, I checked the VRM temperatures; it was fine," but they weren't running like GrowMax for 24 hours, and
Yeah.
then it was not fine when you're doing that. But we've got some high airflow cases like the Fractal Torrent, and it seems like that case handles server boards really well without being super loud.
Patrick Kennedy from Server Home, when he does his server testing, he puts it in a hot environment, so he has the server above it and below it in the rack running for a good 8, 12, 16 hours beforehand, so it heats up the area even if you've got airflow.
Hmm.
great
Yeah.
if you have that facility.
Yeah. Yeah, sometimes those rack cases, they'll have vents on the top and bottom, which is great, unless you've also got servers above and below the existing server. And then it's like, well, come on,
Yeah.
guys. Come on. And not only that, but on this live stream, what was taking me so long to get set up is if I switch angles here, I've got the machine. We're right here with the 64-core Milan-X. I can run arbitrary commands.
So this is where I should point people out that I'm streaming on my channel, Wendell's streaming on his channel. To see him benchmarking the server, you're going to have to go over to his channel or watch them simultaneously. This is a live recording, and I should give a shout out already to Erkin. Thanks for the super chat. I think this is a live stream playback from tape. No, this is live.
They always do
live.
that. They always do that, and they're like, "It's the taped." It's not.
This is a live stream where we're talking about AMD's launch today of EPYC Milan-X. This is the same Milan processors you know and love, but with an extra 0.5 GB of V-cache plonked on top per CPU. So now you have servers with 1.5 gigabytes of L3 cache, or to put it more accurately, a single core can now access 96 megabytes of L3 cache each. Unless you run it in one of those 8 core, they go down to 16 cores, don't they? We'll get to the SKUs in a bit, but
they go down to 16 cores, nice. But even the 16 core is still 3/4 of a gigabyte of cache, which is bananas.
Yeah,
absolute bananas.
Watts and,
Yeah.
So it was a case of AMD reached out to you last week for a briefing.
Yeah, they were like, "Hey, oops, we forgot. We're releasing some stuff." And it's like, they've obviously got the computational fluid dynamics workflow down pat, but the question was, what about compiling and software stuff? And so their question for me was, can you look at this in the context of compiling software and compiling kernels and doing that kind of stuff? And I got some of the benchmarks pulled up on screen here because it's crazy. You have to have a compile job that is big enough to overrun 256 megabytes of cache. And that is a non-true, that's not the Linux kernel by itself. It's maybe the Linux kernel and modules, but not even that really. It takes a lot to overrun that.
Like compiling Windows. Maybe.
Or that's like real life computational fluid dynamics. There are some things that are like that, but it's just.
I'm going to start pulling up slides, just so we can go over what exactly was announced today, and let's make sure that everybody knows what's going on.
Oh yeah, that's a good idea.
Because I bet some people haven't been sticking with the news. But if you're watching my stream, I've got the first slide up deck, and it says EPYC 7003 series processors with AMD 3D V-cache technology. And I've got a picture of it here, but you can see it much clearly on the screen. You've got same EPYC we know and love, Zen 2, Zen 3, except there's a little bit of extra silicon on each of those chiplets, and that's where the V-cache comes in. I think I've exhausted about as much as I want to say on V-cache now. We've been going through it since Computex last year with the Ryzen chips. But we always knew that the technology was a big play for the server space.
Yeah, I mean it is the same silicon. They're just stacking more silicon on top of this, which also paves the way for other creative things they could do in the future. I mean, cache interconnects require a non-trivial amount of copper interconnects, and they have to work fairly reliably for cache. Yeah. So it is exactly the same Milan core, just with gobs and gobs more cache. And that was one of the other things for like qualification. So like some of the people that we talked to, like the whole Microsoft Azure thing. They're like, yeah, I mean, we know Genoa's coming, the new socket is coming, and blah blah blah. But we've already qualified this socket across 2-ish generations, and this is just drop in. So it's a no-brainer in terms of qualification. We can just drop it in, and that's exactly what they're doing.
And go.
Yeah.
It's Azure is the first set of cloud instances with Milan-X. They've got a ton of data already out there.
Yeah, HPC, they're available now. You can go sign up and you're good to go.
And so I did ask an Azure expert where if they're replacing all their Milan with Milan-X processors, where are the Milan processors going? And he said you can't get any. We've already earmarked them for something else. Unfortunately. Every so often when one of these big hyperscalers does a hardware update, some stuff sometimes funnels into the rest of the market, right?
That's where my Xeon 8124M CPUs came from. Intel made a sweetheart deal on moving from 18 to 28 cores, and you could get those at fire sale prices. And they're still perfectly fine CPU.
I'm just slowly flicking through the slides here. Some of the so this is what we got in the briefing. Some of these are just kind of like AMD marketing materials. We need to get, the new node introduction rate is slowing, Moore's law, and more than more type performance needed, and innovation required, and it's a story that you hear a million times in this job. But AMD sensed the opportunity of cache because SRAM scaling is different to other types of scaling. So the Vcache chiplet is actually using double density SRAM compared to the main core chiplet, which is actually quite impressive.
Yeah, I'm kind of
in the same space that they were able to put 32 megabytes, they can put 64 megabytes and jam it on top.
I'm cheating here a little bit. I've got the slides pulled up from Hot Hardware, so.
Ever since I left Anandtech and I've moved more into the video space, I've noticed that no YouTuber influencer uses anybody else's video as reference. They use the written media as reference.
It's because it's too hard to pull up a video and get to a specific slide. It's just like, and I can't. The advertising is taking over. I'm not having a good time here.
Some people are saying you're too loud on my stream. Some people are saying you're too quiet on my stream. Let's see if that works. I'll turn myself down a little bit, maybe.
VC Jester asks, so what should I do with my Epic CPU now? Put a wing on it and a loud exhaust and pretend it's fast? Listen, it's the same Milan cores. Unless the job that you're doing wouldn't fit in the cache memory before, you're probably not going to see a huge performance uplift. That's why we've got some content coming that's going to be using AMD's MicroProf, which will give you, a heat graph that shows, the thing that you're running, what is the L3 hit rate? If you get a really crazy L3 miss rate, it doesn't necessarily tell you anything. But if you get a crazy L3 hit rate, you know that more L3 cache is not going to help you.
It's I was having a minor Twitter discussion about this. It's Milan-X exists today not in search of a problem, but because a problem already exists. For the type of workloads that need it, whether it's EDA, CFD, and we'll go on to a few of those because AMD actually did some really good collaborations, I think, for this launch. At least for the few guys they showed it to. In your video, you went through a couple of those.
Yeah, I definitely agree. And that's the great thing is that you get the feeling that AMD had been talking to those folks since Rome, and finally they're like, okay, yeah. And with things that are, physical simulations, things don't necessarily fit neatly into a 2D array. It's like, assume that the Earth is a sphere, and it's like, well, hang on a second there, Chuckles.
It's that whole thing to do with data you can either think of as scalar, vector, or matrix, which we all understand. But what if it's essentially pointers to lists of pointers to lists of pointers? It becomes spatial. You don't know where the memory accesses are. It's really hard to know what to pull into cache. So the more cache you have, the better chance you have of hitting that data. Which is kind of like what FPGAs are good at that. But if you wanted conventional CPUs, this is what this is for. I've pulled up the slide on the 3D opportunity, just showing how AMD is moving from chiplets on die to interposers and then actually stacking 3D, because they're using TSMC's hybrid bonding here, and I think the pitch is down to 9 micron,
Yeah.
whereas Foveros is at 36, if I recall correctly. So
Yeah, it's the there's so much. I guess what I was thinking of is, okay, we've got cache and we've got a crazy density SRAM cell that's optimized for TSMC's process, but that kind of a bus interface, you could put a lot of other things there as long as it's not going to generate an excessive amount of heat to have competing energy dissipation for the rest of the CPU. So who knows what sorts of other mad science AMD is cooking up with that type of interconnect technology.
TSMC has demonstrated 12-layer hybrid bonding in 600 micron height, but that's just essentially blank silicon with TSVs running through it. Once you start putting in logic, obviously that requires power, and then it all becomes more of a power management scenario. What you thought was a hotspot wasn't a hotspot before, now becomes a hotspot because your dissipation methodology changes. And part of the research in this area is actually how do we actually manufacture SRAM on top of cache, but in the same silicon wafer. That's when we get into in silicon 3D stacking, and that's a lot more difficult. It's in the research papers right now. It is really interesting. I've got the slide here just on hybrid bonding, just showing what they essentially, instead of putting solder balls and putting them together, you're actually just putting two wafers on top of each other, or two chips in this case, chip on wafer, and you get it right on, and it essentially binds itself to itself, and that means you can have a lot smaller connections. Smaller connections means better power efficiency, and lower latency as well.
Yeah, not only that, but the thermal characteristics of a CPU that gets really hot from doing work and then is colder when it's idle, and then it gets really hot from doing work. It's a lot of thermal cycling, and there's a lot of opportunity for mechanical failure. And having also gotten that right, apparently, is probably a big engineering challenge.
We sometimes forget that different metals expand at different rates under thermal load.
Yeah.
So you have to take account of that as well, especially when you put in this sort of hybrid bonding. The slides I'm going through now are just talking about the fact that these Zen 3 chiplets in Milan already had the TSVs. They were already built in. We've known this for a little bit now, but
Since
plan
Rome, you mean?
Was sorry.
Since Rome.
No, Rome Zen 2.
Yeah.
I thought it was Milan, since Milan Zen.
Uh-uh.
TSVs were in Rome.
Yep.
Okay. Yeah, so it's just a case of we'll put it in, and then we will intercept it with when the technology is right, when the technology is ready.
It's exciting.
So the question then becomes when they do the core chiplet on a different node to the cache chiplet.
Soon,
It's the future.
I mean, you could make the argument that it's kind of different because, I don't know, but my impression of it is that because they're using the SRAM library direct from TSMC, it is as optimized as it possibly can be. Otherwise, there is this kind of translation layer from like the physical layout and floor plan package into what is physically possible with TSMC's process. And so, the SRAM part of that has been, it's not really a different process, but if we're going to call, like 7 and 7 plus and 7 plus plus and 7 plus 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 a thing.
7P, 7N, yeah.
Yeah, then it is kind of one of the most optimized, one of the best examples of a process at peak optimization, I think, because it is bananas that it's like, oh yeah, 64 megs in this is no problem.
there's also Vcache on the Ryzen 7 processor that's coming out April 20th. And
Yeah.
there's been some, talk there about they're not allowing overclocking because the voltage of the 3D Vcache doesn't go much beyond 1.35 volts. Part of that is because they're using those high density SRAM libraries. The higher density you go, the less sort of wiggle room you have for that sort of thing.
Yeah.
They could have made it just an extra 32 megabytes of L3 cache, stuck it on top, and it probably have the same characteristics, but they're trying to jab 2x that in the same area,
Yep.
which removes that wiggle room.
Now, I seem to recall at some point somebody saying something about they could even go more stacks more higher, like they could lay it layer on, but then there's a latency penalty, and probably one stack was the sweet spot.
I've pulled up the slide here on just showing the difference between 32 and 96 meg L3 cache. It's slide 14 in the deck, and at the bottom right here, it's saying still got 16 way set associative, but plus 4 cycles latency. That's what the cache brings. And this borne out actually in our testing. I saw plus 3 at the low end. So, and 2 terabytes per second bandwidth. And have you done an L3 stream, or have you just done a DRAM stream? I tried to run an L3 stream on your system, and it blue screen.
Yeah, Windows doesn't like that.
Too fast, slow down.
It really is, and I think that was a Server 2022 thing, because Server 2022, for their idea of protection in Server 2022 is, this looks suspect, we're just going to blue screen. So that's why the Windows subsystem for Linux also blue screen. So it's just like, come on, guys, come on. But the efficacy. One of the really interesting things is that for almost all of the workloads that I benchmark, there's not a linear relationship between the amount of cache and the amount of RAM. The more cache that you have, it is able to effectively cover exponentially more RAM for larger data sets. So at least for the kind of stuff that we're doing. So in terms of like, is it 3 or 4 extra cycles of latency? Because most of the really giant workloads that I'm testing are almost always memory bound, it doesn't really make a huge difference.
Yeah, you'd much rather have those extra cycles of latency, even if it goes out to like plus 20, rather than having plus 200 by going out to main memory. It's the whole thing about being able to optimize software to work within caches is a serious effort. And suddenly when you have more cache to play with, you can do more, and we'll get to the aspect of superlinearity, I think, in a bit. But on a certain aspect, it also makes you lazier in your coding.
Yeah.
It's when we started getting large memory systems in itself, programmers got lazy. I've got the slide of the CPUs up if we want to go through exactly what the 4 new Milan-X models are.
Oh yeah, there's 4 of them. That's good.
So really, you need 2 of each.
Hey, the 16 core, 2 of each, that makes a lot of sense for a lot of things that are licensed per core, because that is maximizing the amount of cache that you get per core at every level. Well, I guess it's really just level 3, but when we're talking about
every CPU on this list has the full 768 megabytes of L3 cache. So when you're going for the 16 cores, you've got 8 chiplets. That means 2 cores are sharing 96 megabytes of L3. So cache per core for things like EDA, for things like CFD, where having as much cache per core is needed, it's a win-win. And so we get 64 core, 32 core, 24 core, 16 core. Base frequency 2.2 to 3, turbo 3.5 to 3.8, 280 watt, 240 watt. On the 64 core models in Windows, I was seeing about a 2.9 to 3.1 gigahertz all core boost on the 64 core models. Um, though I also noticed that it was saying it was in 225 watt mode, but you saying that was having problems on the system.
Yeah,
Or it was set at 280, but it was showing 225.
yeah, I think that's just. I don't know if that's because the Daytona platform has always had problems reaching at least going from 240 to 280. On the Linux side, I did most of the benchmarking on that configuration, and it was in line with the other 7763 benchmarking I did on the platform, which was about the same as 240 watts. But on the Gigabyte platform, it fully unlocks the 280 watt, and then you can you can really get some significant performance uplift there, but greater than 10% in some cases.
It's so AMD sent out the when AMD launched Epic first generation, the system they brought out for everyone to test called Daytona was built for Naples, and Naples only went up to 225, 240 watts at the time. But because of socket compatibility for second gen Epic, for third gen Epic, for now third gen Milan-X Epic, they've kept the same platform for reviewers to use. Whereas if you take the newer systems like the Gigabyte Wendell was talking about, those were built for Milan from the start. So they were designed to run at 280 watts per CPU. They've got the right thermal delivery. They've got the optimized firmware. And I remember with Milan, we were seeing a 10% increase going from the AMD Daytona system to a commercial Gigabyte system, and that's more akin to the performance. I mean, I think the difference is going from Cinebench 100K to Cinebench 110, 115K.
Yeah,
multi-threaded.
close to 100K. Yeah.
Which, just one run of Cinebench takes 4 seconds. It's kind of a bit stupid. So
It's got to heat up for like 10 minutes or so.
Mm. But prices, AMD doesn't usually produce the 1,000 tray unit prices. Normally they do suggested e-tailer price, but for these CPUs this time around, it's the 1,000 unit tray price. $8,800 for your 64 core, down to $3,900 for the 24 core, and the 16 core is slightly more expensive than the 24 core. AMD's done this before, haven't they?
Yeah, it's to do with the per socket licensing costs, but it makes sense because the 16 core is like they probably don't have chiplets that are bad in that way. So those chiplets could be sold at a higher bend part. It seems like the yields in general are really, really good. And the cost of the 7763, like, look, if you're building a 7763 system, and I'm telling you that adding more cache doesn't hurt you in any workload that I found, and the 100 megahertz boost difference is marginal at best, then the FOMO in you as an administrator should be like, well, I should just go ahead and get the Milan-X CPUs because the total cost of the system, even at $800 more per socket, is a rounding error. Because the entire rest of the system is going to cost so much, especially if you put in, a terabyte, 2 terabytes of memory, an extra $1,600 on the total server cost. You'd be crazy not to get the extra cache.
Yeah, I mean that's literally what it's there for. So, $200 difference on a 20K system. Rounding error. It really is.
Yeah.
Plus, also the 24 core is 3 cores per chiplet, which is a little bit of a not a power of 2 friendly environment, but some people want them.
Yeah, I noticed that in a lot of the EDA type workloads too, when the guys were talking about their clusters, and it's like, oh yeah, there's 42U racks of 1U servers outfitted with these blah blah blah. A lot of the time, those were not high core count CPUs, exactly because they needed the memory capacity more than they needed the cores, because the cores they were able to keep the cores fed because it was really just churning through big data sets and lots of memory, and so you had a bigger effect from more cache from those cores.
We're so used to thinking about workloads as being compute limited, whereas this really is memory limited, workloads. You have to if you're not used to dealing in memory limited workload type environments, you have to kind of flip a switch in your head and realize, it's not raw performance. That's not everything I want. So
Yeah, yeah, and the superlinearity sort of plays into that too. It's a fun new word. It's like, what's superlinearity? And it's literally the math problem where it's like, 4 painters can paint a room, but then 8 painters can paint that room faster than twice as fast as the 4 painter version. What's going on? And
you gave them better equipment.
it was
That's literally the analogy, right?
yeah. It's 10.9x speed up for certain size jobs.
We were shown data from AMD's partners of literally going from 32 core Milan to 64 core Milan-X, and you think, okay, double the cores, double the performance, but because you've now got 3 times the cache per CPU, that's where the superlinearity comes in. You get more than a 2x improvement.
Yeah, and this is going to factor in to some of those jobs that run on tens of thousands of cores, because it will actually make more sense to have the job scheduler look at it and say, because if you slice it into pieces that are too small, you make systems busy unnecessarily that could be doing something else. And if the slices are too big, then you don't get that much of a speed up. I mean, the worst case scenario speed up, I think, in a few edge cases was like 0.97 or 98 or 99x, which has run-to-run variation, so that was probably, n equal 1 in that case. But the other worst case scenario was around 10%. But if you sized the job right, then you could get an 80% speed up. And so when we're talking about a cluster, instead of running it on as few machines as possible, you should run that job on the number of machines that makes your speed up 1.8x. And then the rest of the machines can be running some other job.
We used to think about these massive clusters with thousands upon thousands of cores back when we had dual core and quad core chips. Now we've got 64 core chips. I don't think the zeitgeist of the tech community, especially in what we play in, hasn't really considered that there are still workloads that need hundreds of thousands of cores. Right? It's the example was given by ANSYS, and I think you played the demo on the video on your channel. They were simulating a washing machine with the equivalent of 1 billion cells, which required a minimum 30,000 cores.
Yeah.
It's the whole point of those simulations is if you imagine it as a regular 3D grid, you want to simulate a little bit of the grid, but you need to transfer data what's happening on the edge of that grid to the other CPU core. That's called the halo. And you have to be able to transmit the data of the halo across essentially your whole infrastructure for every time step. And optimizing the size of your grid and the size of the halo for the cache and for the connectivity is going to be key. I mean, the Azure instances that are now available, the HBV3s, they're running 200 gig InfiniBand, if I remember correctly. So
Yep.
This is not only do you need cache so you can access data quickly, you also need connectivity, and compute comes a distant third.
It's funny because the InfiniBand is a big part of the high performance compute part of the Azure stuff too, because at least personally, when I've deployed solutions in the Google Compute Cloud, it's like you're not necessarily guaranteed great connectivity between your VMs or your containers. They're working on that, and it depends on what you're doing for that to matter. But for the high performance compute stuff, the InfiniBand makes a big difference in terms of being able to shuttle your data around and keeping everything busy. But it is a big vote of confidence that Microsoft is basically saying, okay, we're going to just deploy Milan-X immediately in all these SKUs across all of our high performance compute, and then reuse the other Milan chips and other non-high performance compute instances. And it's like we've been saying, it's the same core, it's just with more cache. So it's not like
drop in.
Yeah,
it's just drop in. It's the same TDP, same thermal performance. You lose a little bit of frequency, but because your cache is a lot bigger. Again, you're not in compute limited scenarios. If you want these, you're in other limited scenarios. And
Yeah.
the slide I've got up is just the generic slide showing, CFD, finite element analysis, structural analysis, EDA. The demo AMD said is that they were able to simulate using EDA tools their own high-end GPU almost 2x faster using Milan-X than Milan.
Yeah, that's the 6900 XT. They showed us demos of that. At one point they were logging into the terminal and making everybody nervous. And it was like, no, it's fine. We're not going to leak out any privileged information from this way. It was more like, look at the load average, and it's like, oh yeah, no, this makes sense.
Bigger number goes bigger. That's basically it.
We've had a couple
Yeah.
people in the chat ask, is like, well, but it doesn't make any sense to them that it's the same TDP, 16 cores versus 64 cores. How does that work? And it's like, well, it's the bathtub curve. The bathtub curve will get you every time.
Well, it's also, they say 240-watt TDP for those 16 cores. Take out 50 of that because that's the I/O die, and out of what's left, of the 190 watts, you may not even go that high, right? TDP is a design point, not necessarily the peak operating, especially for those lower core counts. For the higher core counts, that's what it will operate at. But yeah, no, that's a pure compute. It's meant to be pure compute power virus peak potential that you have to design for. With some of these workloads, again, you're putting low IPC because you need lots of cache, and you're waiting for that memory to come from cache, to come from DRAM, to come from across the network. So you're not loading up the execution ports on your cores as much on these workloads. And the future of workloads is going to be based on interconnect and how close you can keep the data and petajoules per bit and all these metrics. The demo that I'm just talking about with the 6900 XT on this slide here, AMD saying going from 24 jobs an hour to 40 jobs an hour. And they run, did they say they run almost 1 million jobs a week?
A day.
And just a day. And just their RTL verification takes up 60% of AMD's own data center resources.
Approximately, yeah. I mean, these are back of the envelope ballpark numbers, but yeah.
Yeah. So, and of course, AMD is, drinking its own Kool-Aid because you would expect their infrastructure to be powered.
It's called dog fooding. They're eating their own dog food.
but it's great. We have this concept of AMD processors designing AMD processors.
Yeah.
But in the same way, Intel uses Intel processors to design Intel processors.
Yeah.
It's not necessarily new, but
yeah, I like the TDP part is also pretty interesting because the higher the TDP, the higher the clocks will be for a given part. And so like the 16 core, you can expect to turbo more and more all the time. But there's also the whole concept of a CTDP, a configurable TDP. 280 watts is too much for some data center customers, or apparently. When we're talking about 1U pizza box densities. And so, you can elect to run your CPU at a lower temperature, but if you've got the cooling capacity and you want to run it at 280 watts, you can. And if you do, you will see higher and more sustained boost clocks. I've got the 8-core EPYC, and at 280 watts, it's basically never not 3.9, 4.0, 4.1 gigahertz. I mean, it's 1 core per chiplet, and it still doesn't even really get super warm. And yeah, it's using north of 240 watts of power in some scenarios, but it's basically max turbo all the time, and it's great. It's glorious.
It's a shame the I/O die is sucking so much. It's sucking a bit of that. I mean, we've had conversations with AMD about this. In the future, is the I/O die going to use less power so you have more available for the cores? And the idea is
it
should. It has to. Yeah.
There's
Go
ahead.
I was going to say if we're reaching a realistic thermal limit or TDP limit of CPUs in a data center to be cooled by air, the only way you're gonna be able to push more power through those cores is if you save power in other places, such as I/O die and connectivity. So,
Yeah. Uh, Not only that, but some of the anomalies that we ran into in the past when we were doing benchmarking lots and lots and lots of I/O workloads, even though the I/O was maxing out the bandwidth on the bus, it still seemed like something weird was going on. And it turns out that it may have been power management. Like the entire rest of the CPU was so not loaded that it was saying, go ahead and go to sleep. But then that would create sort of a backup on the bus because then the bus wasn't being serviced quickly enough, and then the CPU would have to wake up. And going to sleep and waking up takes an amount of time. So there is actually a utility. AMD published a utility at the beginning of 2021 that will let you tweak the power management facilities on the fabric, and that helps really tremendously I/O heavy loads, and it helps keep the links and the cores from entering a light sleep during periods of heavy I/O because the cores really aren't super busy in that time. But yeah, higher power usage. But
I remember Forrest Norrod, who heads up AMD's EESC, Embedded Enterprise and Semi-Custom Group, saying that for certain customers with customized EPYCs, you can overclock the Infinity fabric because they have workloads where the interconnect needs to be jumped up, and they do extra qualification, and they pay a bit more for that. So
off roadmap SKUs, all right. I can't wait.
Yeah.
Can't wait for DDR5 server memory.
You mean approaching 1 terabit of bandwidth?
Yeah. Probably not going to help any on latency, but throughput is good.
Yeah. I've pulled up the full processor deck, the table I sent you over Discord, just showing all the different Zen 3 processors. AMD also puts Zen 2 EPYCs scattered around, but I've not included them here, just showing that each one of these new Milan-X CPUs really is meant to be the top model for each of the sections.
Hey, Jake from Linus Tech Tips is here. How's it going?
Hey, Jake. Yeah, but whose stream is he watching?
Probably not mine.
It sounds like yours. Not mine. But depending on how you want to compare the CPUs, the extra Vcache is about... I know you said in your video it's about plus 800, plus 1,000. I think it should be compared to the non-Fs. So it's about a plus 2,000 increased.
Yeah, I mean...
And that
fine.
kind of makes more sense because you're using much more 7nm silicon, right?
Yeah. But also you get the impression that TSMC can make these all day long because they're super tiny.
Yeah.
I mean, using you got that equation that you did where it's like the defect rate in the thing. You should plug that in and figure out, like, based on like what your guess of TSMC's defect rate is, how many of those SRAMs they can get on a single wafer, because it's probably an ungodly number.
Let me do a quick math. Because wafer yield calculator.
So from a single die, they can enable 200 Milan-X CPUs with its 8 chiplets or something just insane like that.
Yeah, so this is probably going to be slightly off, but 6.5 by 6.5 millimeters on a 300 square millimeter wafer. Defect density on 7nm is 0.07. That's defect density. That's not yield. That's so you still have to bin for voltage frequency response. Reduce the edge loss down and the scribe lines because you can minimize those, and you get about 1,500 dies per wafer.
Yeah, so divide that by 8, assuming that they don't lose any in the assembly process.
Yeah. What's that? 187 epics per wafer.
That
But
seems like pretty
okay,
good.
so ballpark about $20,000 per wafer. Yeah, we don't know the exact numbers because uh, that means per chiplet it's $13. So 8 of them is 100. Yeah.
Yeah,
If you,
that tracks.
but then you have to package it, and that doesn't include the other yield factors. So say double that, 200.
Still,
So AMD is getting a good return here.
yeah, yeah. Well, and any that didn't qualify for Epic, I have a feeling that's what we're seeing in the 5800X 3D. It's like, oh, this is not going to work for Epic. Here, have your gaming CPU.
It's also the with the Ryzen, the so with Epic, your kind of workloads and environments are very well defined. So when you create that product, you can make sure it works in that well-defined zone. For a commercial product to end users, the zone's a bit bigger. That's
Yeah.
why they've said, no overclocking and it's only one SKU and that sort of thing. So
Yeah. And a lot of consumer workloads really won't benefit from an enormous cache. Gaming apparently does, but a lot of other stuff doesn't. I was kind of surprised that it like if we size compile jobs, at the low end, it's actually the Linux kernel. The Linux kernel is really not super huge compared to everything else, and then it's probably like
20 seconds.
Yeah, just for the kernel, yeah. Chrome and Chromium is a little bit bigger. Open Embedded, compiling all of Open Embedded, used to be called Yocto Linux. That's a little bigger, and then at the far end is doing something just really completely insane. The other variant of the Linux kernel is compiling all of the device driver modules. That actually parallelizes really well, and even on a dual 7763 non-X, you're in the neighborhood of about 30 compiles per hour, which is pretty fast. But for compiling the kernel, Milan-X doesn't help. Compiling the kernel plus all of the modules, you can speed up from maybe 30 to 35 kernels per hour. But like with Chromium, it doesn't really. I mean, it speeds it up very slightly, maybe 10%. But if you run multiple compile jobs at the same time, it actually does help. Context switching. That's where I was like, well, what if I could run 2 or 3 jobs in parallel? So context switching, when you have multiple jobs that will fit in cache together combined, those see tremendous speedups. So then it's like, oh, well, of course it makes sense for cloud providers because their jobs are constantly switching context for all the different customers because definitely the machine is oversubscribed.
VMs, services, containers, Kubernetes.
Yeah.
Yeah. I pulled up the task manager from Windows with this thing 100% loaded. Just because I want to show 2 sockets, 128 cores, 256 threads, all running 100%, 2.9 gigahertz all core, and it's this one right at the bottom here that says L3 cache, 1.5 gigabytes.
Yeah.
It's insane. So this is not L4, this is just L3. You can't run the system without VRAM. You still have to have VRAM in the system. I'm under the impression that Intel's Sapphire Rapids with HBM might be able to run without memory because you use the HBM as a 64 gigabyte memory space, though that for a server is pretty small. And you can't use this L3 cache as a user accessible area. I've seen people suggesting, let's put Doom in it, or let's put a variety of other things, and it doesn't work like that, unfortunately. You have to load it in once, and then hope it still stays in cache as well. So.
Well, I thought of one way we could do that, and that is to limit the amount of memory to like 96 megabytes of memory. So we've got enough room to load, DOS and Windows 95 maybe.
So MS-config has the option to limit the amount of processors that Windows boots into. Just limit to 1. See what happens. Yeah. It's
Yeah, come
It's
to think
a
of it, I don't think Windows 95 could deal with multiple processors. I think you had to have NT or 2000.
Yeah, you have to limit it down, don't you?
So that
So
it would have to be, at that point we're basically talking about one. So it'd only be 96. Yeah, it'd only be 96 megs. You could only get it to run in 96 megs. Somebody, whenever the 5800X 3Ds come out, somebody's going to do that.
I'm so the slide I'm now showing up is the result of the memory latency testing, which I think is pretty important for these chips. This is a simple memory latency sweep. So if you're not used to the whole concept of caches, imagine it like a long road, and you've got different stages. And so if you want to go, say, half a megabyte out and back, how long does it take to get there and back? And this is essentially what this test is. So on the bottom axis, you've got the depth of how far you want to go out, and on the y-axis, you've got the number of clock cycles it takes. And so we've got L1 cache at 4 cycles, L2 cache at 10 to 11 cycles. That stays the same between Milan and Milan-X. But the L3, AMD said +4 cycles for the L3 cache, and we're kind of seeing that here. So on the low end, we're going from 42 cycles up to 45. But the key point is when you go beyond that sort of 1632 megabytes of L3 cache per core, all the way out to 96. And you've just got this long extended line for Milan-X that goes all the way up to 89 cycles. All the while that normal Milan has to go up to main memory, so it shoots up to 282 cycles, or 3 times slower. And that's where the benefit is of this core. But in the same way, so one of the earliest questions I got in my chat was that AMD has said that this cache delivery system won't help regular workloads. Help gaming, because gaming has the need to put data into a lot of data into L3 cache and then shove it across the PCI bus to the graphics card. But regular workloads that everyday people use aren't going to see a benefit because they don't have that much cache pressure.
Yeah.
The point is, if you've got 8 cores all thrashing your L3 cache because it needs the data, then yeah, you might see a difference. So we're likely going to see things like compression and decompression perhaps get a benefit from this. But aside from that, there aren't any regular user workloads, as in non-workstation workloads, that will really put any extra performance on the Ryzen chip. That's why perhaps this is more focused towards the Epic Milan-X, and AMD can charge a pretty penny. I mean, if AMD wanted another $2,000 for that Ryzen CPU, nobody would buy it. But
Yeah.
there are
Yeah.
some people that argue that the price of that Ryzen CPU is a bit too high anyway.
Yeah. Well, we'll see when the benchmarks come. Maybe it'll be worth it. Maybe not. I don't know. We'll see.
Coming 420.
Mark Rose says, how much faster does it compile kernels? Well, you go from about 30 to about 35 kernels per hour under certain conditions. See, your compile job has to exceed 256 megs of cache. So, not a tremendous speed up.
And, so that's it for my slides. Brief coverage, extended coverage. I mean, you've only had the CPU 6 days and you're away for a few of those.
Yeah.
So it's I know you've got benchmarks with Glenn Berry coming up.
Yep.
Speaking to him a little bit on Twitter about where these CPUs fit in.
And the Phoronix benchmarks are out, and so you can check those out, because a lot of the benchmarking I'm doing is also with the Phoronix test suite on Linux. And Michael, all he did was the straight up just disable the cache in BIOS. So it's literally the CPU with and without the cache disabled. So if there's a very slight difference in thermals or clocks or whatever, it's there. And there's a surprising amount of workloads other than EDA that show a significant uplift. Just depends on what you're doing. Cinebench is one of those, though, where Cinebench is not going to show a huge uplift because Cinebench was already, a small enough job, it basically lives entirely on the CPU anyway.
Yeah, and for as much as people like it as a load generator, it isn't that heavy on the execution ports either. I mean, it's a good average workload, but it's not the most punishing by any stretch of the imagination. So
Yeah, it's more like how good is your implementation of blah 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 math package. But that was some of the EDA vendors were also talking about the work that AMD has done on their math libraries like Bliss and some other things, and they said that internally they have some algorithms for solvers, and before they had access to this much L3 cache, they would not implement the solver because using that solver on older CPUs was cripplingly slow. But now it's like, oh, now that we have this amount of cache, we can use this other algorithm for doing a solution, and it runs great when you've got 120, 200 megabytes of L3 cache. So,
it's fun when somebody turns around and says using this algorithm is stupid because it's slow because it requires lots of accesses to memory, and then 10 years later a product comes out with so much memory that revisiting the topic again
yeah.
becomes viable. I mean, that's the basis of what my PhD was about, so essentially.
Well, here it is. It's sitting right here. With all of those benchmarks and all of that craziness. Well,
did you only get the 64 cores?
Yep, only the 2. But
so
you can.
They're in the system now. You can't show anybody.
Yeah, it's like you can disable CCDs, and I'm probably going to try to do that and see if that has any effect on the boost clocks or whatever, because the 7763s were like that. If you go in the BIOS and you reconfigure the 7763 to be something else, at least in the testing that I did, it's pretty much in line with everything else. The ones that it's not like are the F series, where they're frequency optimized, but where that top end boost was like 3.35 gigahertz basically across all the non-F SKUs. As soon as you start disabling cores, it starts using the power budget and turbos all the time and blah blah blah. If anything, the 7763 was maybe a little bit better in like the 24 core configuration, like running it with some of the cores disabled. 7763 in a 24 core configuration was basically all turbo all the time, or close to it.
Yeah, it's AMD's. Now that this is out, and the people who need it will accept it, we're twiddling our thumbs for Zen 4 now.
Yeah, that was it's like in the tour of AMD, it's like, can we see everything? And they're like, no, you must not even look through windows. And it's like, you guys are super nervous. And it's like, there's stuff everywhere you can't see. And it's like, sounds good, thanks.
They were touring around the Austin campus, weren't they?
Yeah.
So you got access to the meeting room and the canteen, and that's it.
No, we weren't even allowed to go to the canteen.
Ooh. That sucks.
I mean,
I've been to the canteen a few times.
Yeah, me too. And it's like, no, everything must be locked down. And it's like, okay, sounds good. But no, it was a lot of fun, and a lot to be excited about here too. So.
I mean, the Austin campus is the one that they had to sell and lease back. So technically, they don't own that campus. It's back when money was tough, but now money's flowing.
That's probably a wise thing to do, even for tax purposes, because the U.S. tax system is so messed up. It's like, oh, you own something? Oh, no. It's like, oh, you pay money every month for something? Yeah, take that off your taxes. It's like,
Yeah. So.
Cool. Well, is there anything else we can think of that we want to share with our audience?
Let's see. We've done the basic test numbers. I know Patrick has put an article out, but his basic test suite takes 10 days. So stay tuned for Server the Home on that. I mean, I can't wait to get some of these CPUs in, because I haven't got mine yet, just to test them on the non-Daytona with you with the Gigabyte system.
I'm going to transplant mine later today, so if you want to remote into it, that's no problem.
Yeah. Well, that'd be cool to see if anything changes just going on a Milan focus system.
Oh, it definitely will
And
change
then
because I've done that with the 7763s, and it was like, good lord, what's going on? Ah!
tomorrow is GTC.
Yeah, there's a lot of things happening at GTC, so this week is gonna be busy. Super, super busy.
It's funny if you go to GTC and you look at the agenda, you can tick Grace CPU for the talks that might be about Grace. It doesn't have a section that says Hopper GPU, unfortunately.
Well, they're probably talking about the architecture or plans or stuff that they've got going or whatever. All right, any last questions, chat? Do you think this would help in tasks that require emulating ARM? If you're doing enterprise ARM emulation, possibly. I don't know.
Dean Powell asks, will the cache help you calculate pi? Technically, pi is one of those tests where the more digits you calculate, the bigger the spikes of capacity you need. So the more cache you have, for the steps that require less than that amount of cache, you're really fast. But the more digits of pi you do, the less likely you are to be outside of that cache window. So having, say, 6 terabytes of memory is better than having 1 terabyte of memory for anything that needs less than 6 terabytes of memory. But the more digits you do, the less likely you are to be inside that value. So it's one of those workloads where if you're calculating a small amount of digits, it's great. But the more digits you calculate, it becomes less of a factor, and you're still bottlenecked by your storage.
I would even go out so far out on a limb and say that that's one of the rare exceptions where the memory access pattern probably is truly random, because 99 out of 100 times, maybe 999 times out of 1,000, when you have a 1 terabyte memory working set footprint thing, the algorithm is probably not working across the entire terabyte at one time, and because of that, again, more cache is covers an exponential amount of memory because it's not working across the entire terabyte data set that's in memory most of the time. Most of the time, the algorithm, like the programmer that worked on an algorithm, especially for handling that kind of data, was not a complete moron. And so they're trying to be as local as they possibly can. And so it'll move through in chunks. And certainly that's a big part of the speed up moving to 256 megs of L3. AMD didn't have to do anything more exotic in silicon to figure out, what algorithm was in use. How are they? Is this Shore's algorithm? Okay, we need to detect that in our prefetcher and do something. They're just like, nah, we'll just throw memory at the problem and hope for the best. And so even though it's 3 times as much cache, it can be more than 3 times as effective covering a larger memory footprint just because the algorithms are not usually completely random access memory.
Yeah. Data sets get that large, you definitely have to have sort of scalable manual control.
Yeah. And I wouldn't be
people pay big money for that.
In your latency graph from 64 to 96 megs, I was surprised it went up as much as it does. I wouldn't be surprised if their algorithm is doing something a little bit beyond just, it's not just strictly speaking a victim cache.
If you notice, the Milan version also between 32 and 64 goes up. I think that's to do with cache page sizes and TLBs and whatnot. So
yeah. I think there's a few things like the TLB and some of the other stuff that's kept a little close to the vest, but I don't understand enough about the mechanism to really. I know a little bit about that from working with like huge pages, because that can benefit virtual machines tremendously because you just have fewer pages for everything, for the memory controller and everything else. Yeah. So it can be nice, but then you can potentially have very large blocks of fragmented memory if things are getting moved around a lot. So it's like
defrag your memory.
It can be a problem. So, all right. Well, thanks, chat. Thanks for hanging out. Be sure to check out the videos that we're doing. Yours is coming out. Ours is already out.
Yeah, I was planning to record it today, but other stuff got in the way. Damaged my Achilles. Still in pain.
And everybody should go
Unfortunately.
subscribe to TechTechPotato because you have your own thing now. That's exciting.
Only, but you've also got to subscribe to level 1 text.
Yeah.
That's how it works.
They're probably
That
already
way you
here.
get the full level 1 potato experience. It's Gordon from PC World. Sent over a super chat saying cheers. It's. I think next time we're all in the same place, we should all get together and do a show.
I think that would be a lot of fun.
Sea Swords, thank you for the £5. Is it true the L1, L2, L3 cache is expensive? If so, how much? Is it the same as VRAM RAM? Is it much different? The problem with cache is the size in relation to everything else in the core. At some point, it gets physically impossible to add more cache because you need to put in more memory buffers, more execution ports. That's where the cost is. It isn't necessarily the cost in terms of dollars, it's just the cost in terms of die area.
Yeah, and you don't want to make more than people are willing to buy. You know, it's not. You don't want a huge backlog of. It's like, oh, look at all this stuff that we did. It's like,
So if you want to talk more about this, there's the level 1 text forums.
oh, yep.
You can go over there and harass Wendell over there. If you want to harass me, I have a Discord channel, which you can access by going through Patreon, patreon.com/TechTechPotato. It's $1.50, and I take my advice from Craft Computing on this, because there are some crazy comments out there, but for $1.50, you can post what crazy you like. It weeds out the bots, honest.
That's probably a good thing, and
Yeah.
and probably good. But you're also doing the analyst thing as well. So there's spoiler alert. There are I don't really know what they are, but they buy very expensive computers, and so sometimes I get sucked into. I'm going to build this thing that I'm going to overclock and do all these things and run multiple 8K Dell displays, and I'm get the impression that I'm doing like day trading and crap like that all day. And so they'll probably hit you up, and your Patreon has a thing for that class of person too, I think, doesn't it?
I mean, yeah, it's part of my analyst role for a little while actually has been calls with Wall Street with investors, people who don't want to sift through 20 hours of videos and written content and just want it distilled down. I'm more than up for that. If you have the coin, I have wares. If you have coin,
see also AMD's stock price.
yeah, yeah, and for full disclosure, I do not own any tech stocks. So, and some people have been asking about my T-shirt. Yes, it's a Formula One T-shirt, Chain Bear F1. If you like Formula One, go subscribe to his channel. That's very good. Man, I need to get some T-shirts,
Yes.
plushies, and everything else.
Yes. Water bottle. Jake is still here. Actually, they're doing that. They're doing like the creator warehouse thing. So you should hit up Linus about that.
Already have. I've said when he's ready to accept international creators into the whole merch business, I'm more than willing to be a trial participant.
Woo!
So if you want potato merch, harass Linus.
I'm gonna work on Linus's EFS recovery later. That's gonna be fun. It's probably going well. I don't know. Is it going well, Jake? You haven't let me know. I need to know.
And yeah, we're also waiting for LTX to come around.
Oh yeah, LTX is gonna be fun. I wonder, is it? I don't.
Not this year.
Yeah.
It takes about a year to plan, so.
Yeah.
Next year, 2023.
And it doesn't look like Computex is going to be moved to later in the year either, so...
Yeah, that Computex will likely still go ahead, but because no internationals can get into Taiwan.
Yeah. Well, you can, it's just the quarantine is like a week, and nobody wants to do that.
3 weeks.
Ooh, yeah.
It went down to 2 weeks for Chinese New Year, and now it's back up to 3.
Wow.
So...
Yeah, that's not going to work. Nope. All right. Well, thanks for hanging out, everybody. We will catch you later. I'm gonna wait until I can see myself waving, and then I'll hit end. Oh goodness, that's quite a delay. It's still going. Wow, that's so much delay. There we go.